Welcome to Design Emergency. Design Emergency, as you know, is a platform that my beloved friend and great design critic Alice Rawsthorne and I started at this point 2 and some years ago to talk about designers, architects, and accidental designers that are doing a lot to improve the destinies of the world. Initially it was about the pandemic, then we migrated onto the larger ecosystems that hopefully will survive the pandemic. And so today I have here as a guest a wonderful, wonderful architect. Well, calling her an architect would be kind of reductive. She's an architectural scientist, but her name is Mae-Ling Lokko. She's an architectural scientist, a designer, an educator. She comes from Ghana and the Philippines, but she's been in the United States for a really long time. And she works with agrowaste and renewable bio-based materials. So Mae-Ling, welcome to Design Emergency. So I met Mae-Ling, I can't remember how long ago it was. I always have this problem that I can't remember where I meet people, but it was a long time ago. And she was part of this group of amazing architects and architectural scientists that are centered around Rensselaer Polytechnic in upstate New York and Columbia University and several other academic institutions that are really looking at this new wave of architecture, which is not only about signature buildings, but rather about creating the kind of meta architecture that then will be hopefully used by architects and beyond. I would like to ask you, Mae-Ling, if you were to describe your path to what you're doing today, what would it be to give a sense of how one can get to do what you do?
Yeah, I think, in a lot of ways, the work that I do is driven by sort of a personal motivation that sort of begun when I was a teenager. My family moved to Ghana from Southeast Asia. And at the time, it was a pivotal moment for me because my father was sick and, we spent a good few months outside of school and, sort of taking care of my dad. And so being in Accra, Ghana's capital, I spent a lot of time getting to know the city, Accra, visiting family homes where my dad grew up. And those homes had such a big impression on me simply because they were, they had so much character. They were able to accommodate so flexibly all aspects of Ghanaian family life. And being young, I think the materials are something that I attached myself to. They were the most tangible. But I think throughout, my education and career, I began to realize that that was part of these much larger systems, economic, environmental, social. And so I suppose a lot of the work that I do is really trying to dig deeper and understand how we might rethink all of these systems that ultimately give us the materials that we use and build with. So that's sort of the motivation that kind of guided me. And today I sort of work with a range of collaborators, and I have a company in Ghana called Willow. And what we really do is really work with a range of materials that are largely left behind on the field. A lot of these agricultural skins and sheaths and rinds and stems, which are, to a large extent, not necessarily valued after the fruit is plucked, from the crop that it's supposed to protect and nurture. And these materials have a ton of afterlives that we seek, we're inspired by, and we seek to develop ways of using it in buildings.
I like very much how you say that they get discarded before they've been able to really prove their worth. And I've seen that so much of our attention as architects, engineers, builders, and also politicians is based on this idea of agrowaste. What I find really fascinating is that you talk also about the potential of exploring these materials also to get to some kind of generative justice, because beyond the kind of proofs of concept that you've been able to build, you also have this ulterior motive that we'll get to in a second. Before, I would like to ask you about Willow Technologies and about these proofs of concept. So what have you done with Willow Technologies, and what kind of experiments have you installed that were particularly successful to make to testimony to what you're doing?
It sort of really began with coconut husks, which is a byproduct from coconut water that we all love so much. And coconut food products are found in cosmetic products that we use today. The result is that, the underbelly of that coconut superfood economy has been the generation of this really strong bulk material, the husk. And it was a wonderful material to begin with because it's so strong. It has so many components like lignin that make it very resistant to degradation and very good for a lot of mechanical applications that we need in buildings. And it also is composed of this dust-like substance that is an amazing bioadhesive. So everything in the world of the husk is what we need to reconstitute it into another material. And for that, flagship material, we started looking at a whole spectrum of applications, from things that were as strong as plywood or oak to the more low density, more porous materials that are very good at, absorbing moisture, are very good at filtering all sorts of pollutants, materials that are in the wrong place at the wrong time. And so it sort of began there. And I think in many ways there were successes, but also the failures in that work allowed us to seek other types of plants, crop materials, as well as other organisms like fungi that we use to sort of feed these agricultural waste to grow materials. So there are a range of products from sort of flat sheets that can be used to substitute plywood all the way to more acoustic panels. And we sort of really leverage the sort of art exhibition as a place for experimenting with other forms of production, things that get us out of the studio or the lab and into the realm of not only educate, but also study with, I would say, collaborators, how we might be able to make and build differently in these important moments when we have these cultural exhibitions.
What cultural exhibitions, for instance? Because I remember recently we were together in Singapore and you spoke about prototypes and about the importance of prototypes in our practice to demonstrate what can be done, right? So you showed what you call the mother prototype, which is the one with coconuts. Where was that shown? Where did you install that?
The first place was actually at a contemporary arts festival in Accra called the Chaliwate Festival in the oldest part of the city near Jamestown Harbor. It was very much a sort of cultural program that brought together a lot of grassroots artists and artists from the diaspora to Accra, and a whole series of installations, from installations that went into the slave forts and prisons to stuff that actually were installed right in the streets. And our coconut wall, if you like, was installed right on the street in front of the lighthouse. And we thought it was very important because I think with such materials which are bio-based and they're local, there's this assumption, the social perception that these materials are of low value. And we really wanted to engage with the social perception of these materials. And because of the way the material was designed, it also opened up a different conversation around, what tools, what methods, what forms could be created from, these natural fibers, which we've typically seen sort of thatch, more breathable, perforated facades. Here we had a very strong sort of modular form that curved into a wall. And so that was a wonderful opportunity to engage with, carpenters and masons and everyday people who are looking for materials to build their house with in Ghana.
And is that wall still there? Do you also have an idea of the degradation and how long these structures resist? Because I know, for instance, when it comes to wood, many people have the impression that wood decays, and instead the new buildings that are made of wood have a whole science and engineering behind them that makes it so that they're incredibly resilient. What about coconut?
Yeah, I think the fact that you brought wood into the conversation is so key, because one would treat a coconut fiber board the very same way one would treat wood, which is to install it in places where it's, not always exposed to continuous rain and moisture, that it always, is shaded, it's coated with materials that protect it. And it can live a very long time, as long as what we see with our hardwoods. Where we've actually installed it outside, in sort of we did a climate change exhibition in a wonderful park called the Muffer Foundation in Accra to begin with. And we had a coating on it. It was actually a coating that's typically used in surfboards. So the ocean is a very intense environment, the salt, the moisture. And so those coconut panels are in great shape. Where we don't coat it, it's very similar to the lifetime of a coconut husk, which, there's studies that show it can degrade in the right conditions in a year, some in 10. So anywhere in that range. But I think, this is where kind of the capacity and agency of the architect to allow these materials to be situated in conditions in our buildings that really allow them to breathe, to dry out, to live a good life. That's, I think, where the power of design is. And too often we see other principles, other sort of rules of integrating these materials from homogeneous, more non-renewable materials. Those principles are applied to bio-based materials, which really shorten their efficacy and their lifetime.
What is incredibly important to think about is also of how economically and culturally viable a new scheme of use of bio waste and agro waste materials would be, because you talk about the big four, sugarcane, corn, rice, and wheat, and you say they're 50% of the waste. It seems to me like what you're trying to do is not just to make proofs of concepts in one or two fancy places, and then just be done with it. It seems to me, and I don't know if I'm projecting, that you want to really go all over the world and teach people to work with what they have. Am I wrong to think of that?
No, and I think of all of the exhibitions as sort of building on each other. There probably isn't one body of work or exhibition that we were able to achieve, the full potential of working this way. And so you talked about the idea of how we're very much entrenched today in this monoculture plant economy. And for us, being able to understand the extreme biodiversity of agricultural waste that exists in any location, seasonally, historically, is incredibly important, because all of these materials have properties that are so in tune with their environment, the soil and the climate, that type of recurring phenomena that helps these materials grow. They almost train them to deal with the very conditions that we, as humans have to live in. And so that's very important for us. And also it means that this opens up a much wider inventory of materials. If you like, there's sort of seasonal recipes. Our materials would be made from different things. Different components would last for different periods of time. And so this multi-crop sort of approach to the work is key, because if we scale up, like we've sort of seen, in the corn industry, to an extent that we have so much surplus load in our environment, we end up, first of all, displacing everything else. But what do we do with that surplus, which becomes a huge burden, which then begins to impact every aspect of our lives?
You're talking about surplus of the fruit itself or only of the waste?
Both. I mean, I think always to, what happened, during just right after the Cold War period with corn surplus, right? And the fact that we started looking at transforming it into fructose that has made its way into everything that we eat, or if we need to make it sweet, or into the biofuel industry where we simply burn. And I think that those, large scale applications, if you can look at the rippling impacts of that on, the other plant ecologies, it's incredibly problematic. And so that, I think is a cautionary tale for us to diversify. We can't sustain the health of our soils if we keep growing that way. And that is the ultimate generator of so much value. And that sort of a cyclical, framework in which a series of crops can participate in, so that there is this idea of this long-term, sustenance of not just us, but everything, other kingdoms of life, plants, fungi.
And it becomes almost like a virtuous cycle, because I've seen it also in the work of, for instance, a designer like Fernando Lapose, who works with the corn husks and tries to replenish the tradition and the culture of diversified corn in Mexico. Very often, these materials are like composites, right? There's a fiber, and then there's a coolant, a gel, a resin that keeps them all together. Mycelium has become the hero of design for and architecture, of course, for the past 15 years. Where are we at? You also conducted experiments that brought together also a participation by the public. So can you tell me about your relationship with mycelium?
Yeah, I think I get more and more fascinated the more I learn about fungi. And I think I came to the wave of designing with mycelium quite late. I think a lot of predecessors were very inspiring to me. But that also allowed me to think about what really does this material economy support in terms of labor, in terms of resources, in terms of architectural ambition. And the part that I was very interested in, and again, I think this comes out of maybe a failure in a way of the coconut prototypes, which really required heat and pressure to become a strong material. And, in places where the energy infrastructure isn't as reliable or relies quite heavily on fossil fuels, mycelium opens up quite a lot of opportunity to grow materials with low energy, just at ambient room temperature. It's non-toxic, happens in the course of 5 days. But in doing it and producing the exhibition, and this is one of the pivotal exhibitions for me as part of the Liverpool Biennial at the Royal Institute of British Architects, it also exposed the fact that mycelium eco-manufacturing relies on a lot of plastics, a lot of conditioning. So one has to refrigerate, sterilize. And this, of course, is inherited from our laboratory infrastructure, which, in order to keep things clean and sterile and non-contaminated, we need those materials that will not react, right? Plastics and metals and whatnot. And so I think a lot of the work that we're doing is to really investigate and explore how we might learn from the world of fungi. There's, one strain of mycelium that has been commercialized at scale for design, for building. And it's fantastic to see that scale up. But again, I think it goes back to this idea of the monoculture. And there are close to 8 million strains, if not more, of fungi in the world. We only know 8%. And it's crazy that we're using one to commercialize. So I'm super interested in learning how other cultures have used fungi and mycelium to grow. We know that there's fungi that, digest plastics, some that digest the skin of beets. They're so selective in what they eat, and they produce vanilla. So there's so many sensory, so many horizons for rethinking mycelium production if we open up the range of fungi that are participating. It's expensive and it's difficult, and I think the model for developing requires a kind of cooperation between community labs, academia, and industry, and that's challenging.
And it's happening a lot, I have to say. But it's funny because when people hear mushroom mycelium and corn stalks, or they hear coconut, everybody thinks, okay, yeah, we're going to go in the back in the garden and we're going to just like mix it up together. And instead, there's international regulations, there's safety, there's all of these different obstacles that are sometimes welcome ones that we need to cope with. So it's fascinating to see how much there is still to learn also from other cultures. But so you've been testing mushroom mycelium with corn stalk. You've been testing coconut. What other materials have you tested? What other agro waste have you already experimented with?
So in terms of glues, I mean, we've looked at mycelium for one, but soy protein is another byproduct from another superfood economy. Amazing glue. There's also the coconut pith itself, which is a bioadhesive. In terms of the fibers and particles, we've looked at hemp, bagasse, sugar. We've also looked at a range of food waste, a lot of citric-based peels, which are fantastic, onions, garlics, things that come out of our kitchen. And I think growing territory for us is invasive species. So In Ghana, we work with water hyacinth, which is proliferating the Volta River, which used to be the world's largest man-made lake that was connected to our hydroelectric dam. But, all of the effluent that's flowing into the river means the growth of this invasive species. We've also looked at it in Arles, France, another type of invasive species called Juicy. And then there are other agrowaste that haven't necessarily become building products. One is another superfood. I guess it's going to be the next big thing, called moringa, which is used as drunk as a tea. Moringa oil is also in cosmetic products. But one of the byproducts is actually a sort of flour-like substance, which when you add to really toxic water, like textile wastewater, it makes all the bad stuff clump together and settle, which is a way of treating the water. So again, maybe it makes its way back into a building material with the sludge that comes out of that. But, in the interlife, I would say, there's all these other fantastic applications like cleaning our water that is possible.
Architects of yesteryear, like end of the 19th century and beginning of 20th, used to say that there's a truth to materials, that wood will tell you how it wants to be used, that concrete is going to suggest its own expression. It's like kind of romantic, but does the same happen with the materials that you use, or not really?
Wow, that's a great question. I think that from a compositional, what the materials are made of standpoint, there is these transformation pathways that tell us how to do something with the least amount of effort. So if something contains a ton of sugar, a ton of cellulose, we found the most productive thing to do is to feed it to mycelium, because mycelium loves great, food. It needs that sugar to grow. And when you have plant byproducts that are dominated with lignin, one can sort of mill it into all sizes of fibers, or even to a particle size, and apply heat and pressure to make an even stronger product. So from a compositional standpoint, yes, but I think the floodgates are open in terms of what one designs, because one can mix and match agricultural byproducts. Where there isn't enough sugar, one can add something that contains a ton of sugar to a relatively strong fiber mix. And one can grow it into a brick. One can make it a panel. The ways in which the actual assembly comes through, if it's on the scale of a brick, you have a lot of control. Or if you grow it on the size of a wall, or produce in the size of a wall panel, it follows those logics. So I think the design, there isn't a ton of limitations. I think it opens up rather an expanded vocabulary for these materials to really challenge what we want from our building, what we
And
want from
also,
our...
as you say in your principle, you say it's beautiful. No plant is ever created equal. They are hard to standardize. So a very different approach to the truth of materials. So I wanted to ask you, can you give us an example? Let's talk about this idea of justice through materials. Can you give us an example of what you envision as the cycle, the virtuous cycle of redistribution of power and agency to the different stakeholders? I hate that word, stakeholders on the territory. For instance, what could agrowaste as a building material do to redistribute power and justice?
Yeah, I mean, from a very tangible perspective, we have a ton of folks, maybe not stakeholders, who are right at the beginning of a plant's life cycle. It might be a farmer, it might be a trader who sells the food product. There is a huge gap in terms of what that role could actually be expanded to. So, for example, with agro waste, because we call it waste, it's distributed everywhere at points of sale, and then where people consume them. And they're also of relatively low quality, because no one's really taking care of these materials when they're discarded. So I like to think of coconut traders as an incredibly instrumental actor in this field, because not only are they able to collect and gather at a sort of meso scale, but they are also connected, deeply in these cooperatives that cycle materials between the rural and urban context. Today, they're, especially in Accra and other cities like Accra, where coconuts are sold in the city, it's illegal to dump these materials into the municipal waste system. So they have to burn it at night. And that's an illegal, sort of activity that happens, and how we can leverage that opportunity so that they become part of this, green collar workforce is key. Then there's also the fact that designers and sort of these outlier enterprises that collect waste might be able to come together in a unique eco-manufacturing entity to collect and transform that waste into products of high value. There's so many great examples of companies doing this throughout the world. And often what they tend to do is cycle them back. And I'd like to say not necessarily as downcycling, but it's premature. We're returning it to the soil way too early because there's so many other applications that allow these materials to slowly perform and degrade over time than immediately returning it to the soil. And, that idea of returning, these materials to the soil ultimately is also thinking about nature and, our forestry, our agricultural systems as important actors here. Often, these these agricultural boards are in many ways taking the pressure off our forests, where we harvest wood and timber at these really high rates, and we cannot afforest at the same pace. And so being able to take that pressure off and use the surplus as building materials is a way of also, buying the land and the soil microbiome some time by using everything that the land has already produced effectively. So that cycle of redistribution might be ecological, it might be economic. I mean, I think of what these coconut traders are paid once they are able to collect and pre-process agricultural waste. That's a huge economic opportunity, and that grows the cooperative in a meaningful way.
I see this circularity to everything that is really almost the signature of what you do and of what so many of the people that lucky and hopefully think like you are doing. I have one last question for you. COP27, you were there. How did it go? What was accomplished? What did you accomplish?
Yeah, actually, I was only there virtually on two panels, but it was sort of in relationship to work we've been doing with the United Nations Environment Program, trying to really link building materials and climate change in a very, very concrete way through carbon. And I think, just given the fact that COP is really targeted at policymakers and people who are in decision-making capacities, it was a success in some ways to have these conversations about this ecosystemic approach. Too often we sort of silo our conversations around carbon. In the building sector, we focus so early on embodied carbon, all that energy that is used to process and transform materials, or we focus so much on operational carbon, all the carbon that's used to maintain and condition our buildings. But there is a whole life cycle view, which, if taken together, can completely dislodge some of the assumptions we make when we look at it in silos. And I guess one thing that was, missing was that ability to bring this broader array of folks to the table. And so I think it's important to have these global conversations, particularly, when we look at climate change and the cumulative impacts of how we've developed over time as a planet. But I think it's so important that the satellite, sort of programming really allows, people at the policy making, people who are working upstream to engage with a broad stakeholder framework. And I think that's sort of the ambition of the work that we do, to connect and bring different people to the same table, because that ecosystemic approach is really what we really need to take in order to transform the materials that we build with and our ecology in general. So,
and that's what we hear a lot, policy, 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 and how to insert design into policy making. And it's been really wonderful to listen to you and to know more about your work, Mae-Ling. So we want to also, on behalf of Alice Rosthorn, I say goodbye to Mae-Ling Lokko. Many thanks for participating in Design Emergency with us. And I look forward to seeing you all at the next Design Emergency. Ciao, Mae-Ling.
Paola.